Let's analyze the potential fire hazards associated with different ceiling light fixture wiring scenarios. The first scenario involves two knob and tube wires coming from above the light fixture, passing through two holes separated by approximately 2 inches of ceiling material and lacking an electrical box. This is considered the most hazardous. The primary concern is the absence of insulation on the wires, which allows them to come into direct contact with the surrounding ceiling material. Over time, heat generated by the wires can cause the ceiling material to dry out and become more combustible. Additionally, any damage to the wires, such as cracks or breaks in the insulation, further increases the risk of arcing and ignition. Without an electrical box, there is no barrier to contain a potential fire, allowing it to spread quickly to the surrounding structure. The second scenario involves 3 pieces of 12.2 Romex, with 2 hot wires and 1 switch leg, installed within a metal ceiling box. This option is less hazardous than the knob and tube wiring due to the presence of insulated wires and the containment provided by the metal box. The insulation on the Romex wires prevents direct contact with the ceiling material, reducing the risk of ignition. The metal box acts as a fire barrier, slowing the spread of flames in the event of a short circuit or other electrical fault. However, this scenario still presents some potential risks. If the metal box is not properly grounded, it can become energized, posing a shock hazard. Also, if the wires within the box are damaged or improperly connected, it could still lead to a fire. Furthermore, if the metal box is in direct contact with combustible materials, the heat from a fault could still ignite a fire. The third scenario involves 3 pieces of 12.2 Romex, with 2 hot wires and 1 switch leg, installed within a plastic ceiling box. This is generally considered the least hazardous of the 3 options. Like the metal box scenario, the insulated Romex wires reduce the risk of direct contact with combustible materials. The plastic box provides a degree of insulation, further reducing the risk of heat transfer to the surrounding structure. However, it's important to note that plastic boxes are not as effective as metal boxes at containing a fire. While they may slow the spread of flames, they can melt or burn through more quickly than metal. Additionally, if the plastic box is not properly installed or if the wires within the box are damaged, it could still pose a fire hazard. Now let's delve into some additional considerations for each scenario. For the knob and tube wiring, the absence of a grounding conductor is a significant safety concern. In modern wiring systems, the grounding conductor provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing a shock hazard. Without a grounding conductor, a fault can energize metal objects in the vicinity, creating a potentially lethal situation. Another issue with knob and tube wiring is its age. Many installations are several decades old, and the insulation on the wires may have deteriorated over time, increasing the risk of shorts and fires. It is highly recommended that knob and tube wiring be replaced with a modern wiring system. For the metal box scenario, proper grounding is essential. The metal box should be connected to the grounding conductor in the circuit, ensuring that any fault current is safely routed back to the source. Additionally, the box should be securely mounted to the ceiling structure, preventing it from coming loose and exposing the wires. It is also important to use the correct size and type of wire connectors within the box, ensuring that the connections are secure and prevent arcing. For the plastic box scenario, it is important to choose a box that is listed and labeled for the intended use. The box should be made of a fire-retardant plastic material and should be large enough to accommodate the wires and connectors without overcrowding. Additionally, the box should be securely mounted to the ceiling structure and the wires should be properly secured within the box. Regardless of the wiring scenario, it is important to ensure that the circuit is protected by a properly sized circuit breaker or fuse. The circuit breaker or fuse should be rated to protect the wiring from overcurrents, which can cause the wires to overheat and potentially start a fire. It is also important to periodically inspect the wiring and electrical boxes for any signs of damage, such as cracks, breaks, or discoloration. If any damage is found, it should be repaired immediately by a qualified electrician. Furthermore, consider the wattage of the light bulbs being used in the fixture. Exceeding the maximum wattage rating of the fixture can cause the wires and connections to overheat, increasing the risk of a fire. Always use light bulbs that are the correct wattage for the fixture. When working with electrical wiring, it is crucial to follow all applicable electrical codes and safety regulations. These codes and regulations are designed to protect people and property from electrical hazards. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to perform the work. In summary, knob and tube wiring without a box is the most hazardous option due to uninsulated wires and lack of containment. Romex in a metal box is less hazardous but requires proper grounding. Romex in a plastic box is generally the least hazardous but still requires proper installation and maintenance. In all cases, circuit protection, regular inspection, and adherence to electrical codes are essential for electrical safety. To expand on the potential issues, consider the environment in which the wiring is installed. In a dusty or damp environment, the risk of fire is increased. Dust can accumulate on the wires and electrical boxes, providing a fuel source for a fire. Moisture can corrode the wires and connections, leading to shorts and ground faults. In such environments, it is especially important to use sealed electrical boxes and moisture-resistant wiring. Another factor to consider is the age of the wiring. Older wiring systems may not be up to current safety standards. For example, older wiring may not have a grounding conductor or may use outdated insulation materials. If you have an older home, it is a good idea to have the wiring inspected by a qualified electrician to ensure that it is safe and up to code. Additionally, consider the type of ceiling material. Some ceiling materials, such as wood paneling or acoustic tiles, are more combustible than others. If you have a combustible ceiling material, it is especially important to ensure that the wiring is properly installed and protected. In some cases, it may be necessary to install a fire-rated electrical box or to use a non-combustible barrier between the wiring and the ceiling material. Furthermore, consider the presence of insulation in the ceiling. Insulation can trap heat around the wiring, increasing the risk of overheating and fire. If you have insulation in your ceiling, it is important to ensure that the wiring is properly ventilated. This can be achieved by using electrical boxes that are designed to allow for air circulation or by installing ventilation openings in the ceiling. Let's also discuss the role of arc fault circuit interrupters, or SIs. SIs are circuit breakers that are designed to detect arc faults, which are a common cause of electrical fires. Arc faults occur when there is an unintended electrical discharge between two conductors or between a conductor and ground. SIs can detect these arc faults and trip the circuit breaker, preventing a fire from starting. SIs are now required by the National Electrical Code, or NEC, in many areas of the home, including bedrooms, living rooms, and hallways. Consider the specific requirements of the NEC in your area when installing or upgrading your electrical wiring. The NEC is a comprehensive set of standards for electrical safety that is updated every 3 years. It is important to follow the NEC when installing or repairing electrical wiring to ensure that the work is done safely and correctly. Also, consider the use of surge protectors. Surge protectors are devices that protect electronic equipment from voltage spikes which can damage or destroy the equipment. Voltage spikes can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protectors can help to prevent damage to your electronic equipment and can also reduce the risk of electrical fires. Furthermore, consider the use of tamper-resistant receptacles, or TRRs. TRR are electrical outlets that have a built-in safety mechanism that prevents children from inserting objects into the slots. TRR are now required by the NEC in many areas of the home, including bedrooms, living rooms, and hallways. TRR can help to protect children from electrical shock. Regarding the original scenarios, without a doubt, the knob and tube wiring presents the most significant fire hazard. Its age, lack of grounding, and exposed conductors make it a dangerous relic of the past. While metal and plastic boxes offer some protection when used with modern wiring like Romex, they are not foolproof. Proper installation, grounding, and regular inspection are crucial for maintaining electrical safety. Remember, if you're unsure about any aspect of your electrical system, always consult a qualified electrician. The electrical work is not a DIY project for the inexperienced. It's always better to be safe than sorry when it comes to electricity. When evaluating potential fire hazards, remember that the materials used in the building's construction play a significant role. Older homes often contain materials that are more flammable than those used in modern construction. For example, older homes may have wood lath and plaster walls, which are more easily ignited than drywall. They may also have cellulose insulation, which is flammable unless treated with fire retardants. The presence of these materials increases the risk of a fire spreading rapidly. In conclusion, while the initial scenarios provided a basic framework for comparing fire hazards, a comprehensive assessment requires considering a multitude of factors, including the type and condition of the wiring, the presence of grounding, the type of electrical boxes, the presence of size and surge protection, the building's construction materials, and the environment in which the wiring is installed. Always prioritize safety and consult with qualified professionals when dealing with electrical systems. Remember that electricity is a powerful force that must be treated with respect.